So look at the top. We're going to just real quick review how to factor. Most of y'all should already know how to do this. We've been doing it for a while. If you just joined this class at semester, then maybe the first two will be different, but you've seen them before either way. Okay, look at the first question. What do both of those have in common? GCF stands for greatest common factor, right? So what do they both have in common? An x. So I divide by x. I take my x out to the front. And then I'm going to put whatever is left over in the parentheses. So if it was an x squared and I divided by an x, now it's just a normal x left. Okay, then out of the 4x, I took the x out. The only thing left is the minus 4. Good? Okay, then from there, you set each of those parts equal to 0 separately. So for example, I'm going to let x equal 0, and then I'm going to let x minus 4 equal 0. Now, what you'll notice is that the x equals 0 is already solved. That's the answer. But then for the x minus 4, this is same old thing. How do I get rid of the minus 4? I do a plus 4, so the answer is going to be positive 4. Okay, so that's kind of the exact same thing we always do, is if it's a minus 4 in the parentheses, the answer is really a plus 4. Okay, look at the next one. This one you might not remember. This is called a difference of perfect squares. And this one is a shortcut. So what you do is you square root both of your terms. What's the square root of x squared if I broke it up? X and x. So x and x, and then what's the square root of 100? Plus or minus 10. So I put a plus 10 in one, I put a minus 10 in the other. Y'all remember that? Okay, then from there I would set them both equal to 0, but we're going to skip that step. If this is a plus 10, what's the answer? Minus 10, and if this is a minus 10, the answer is a plus 10. Got it? Okay, last one, t-chart. Set up your t. Negative 7 goes at the top, because remember it's always a times c. Only way to times to get 7 is 1 times 7. To get a negative 6 in the middle, I'd have to do 1 minus 7. Okay, then remember you divide by x. So it's x plus 1, that's a plus sign, and then x minus 7. And then remember that since those are in parentheses and they're set equal to 0, you switch the sign. So what would your two answers be? Okay, very good. Negative 1, positive 7. Okay? So if you know how to do those three skills, then what we're doing after this shouldn't be too bad. Okay, so we are going to talk about what's called points of discontinuity. Okay, so a discontinuity is a value of x that causes the denominator to equal 0. Okay, now here's why. When the denominator equals 0, okay, you're not allowed to divide by 0, so that gives you weird stuff that can happen in your graph. So there are two ways that you can have a discontinuity, okay? The first one is a hole. So for example, you could have a graph that's like a parabola, but then when you get to a certain point, it's empty. We'll look at graphs like that. But you'll have this hole that in your chart, when you look it up, it'll say like error. Okay, because that one number doesn't have a y value that goes with it. Okay, the other type is what's called a vertical asymptote. Now, you've seen that word before, but an asymptote is a line that your graph is not allowed to touch. So let's say, just for example, that you had a line right here. Then what will happen is your graph will be headed towards that line. Let's say it's going like this, and then all of a sudden when it gets close to it, it's not allowed to cross. So it just kind of like randomly shoots up and it can't cross that line. And then a lot of times on the other side you'll have the same thing, where it's kind of like headed towards the line and then all of a sudden it shoots up and it keeps going and going forever and ever, but those two pieces are never allowed to connect because they can't touch that asymptote line. Okay, so remember, this is called the vertical asymptote. And your graph is not allowed to pass through it. So up here, I'm going to put these never connect. Okay, exact same thing here. At your hole, those sides never connect. There's an open space left over. Okay? All right, so here are your steps. The first thing that you're going to do is you're going to factor the top and the bottom. Those are the three things we just practiced. There are three types: GCF, difference of perfect squares, and T-chart. Okay, those are all three ways to factor, okay, which we've already covered. Okay, then you are going to identify the discontinuities. Oh, wait, hold on. Discontinuities, yeah. The bottom solutions. Okay? And then you are going to cancel out any factors that are both on the top and the bottom. Now, here's the difference to know if it's an asymptote or a hole. If it cancels out, it is going to leave a hole in the graph. This is the important part. Put a star next to this. If it does not cancel out, then it is going to give you a vertical asymptote. Okay? So you're going to factor, cancel out whatever you can. The things that do cancel leave holes. The things that do not cancel leave asymptotes in the graph. And then remember, we drew pictures of what they look like. A hole is just where there's a little gap, and an asymptote is when there's a whole line that your graph can't go through. Okay, so take a look at number 1. Okay, and these should go by pretty quick if you know how to factor. So notice the top is already done for you, so I'm just going to rewrite it. Y equals, okay, 8x plus 4. But then the bottom down here, I'm going to have to factor. Now, there are multiple ways for me to factor. GCF, difference of squares, and T-chart. Which one is this? This is a T-chart. Very good. Okay, I'm going to do my T-chart over here to the side. I want my numbers to multiply to 4. So I could do 1 times 4 or 2 times 2. Which of those is it going to be? 1 and 4, because they add to 5, right? So I pick these guys, divide by x, x plus 1, x plus 4. Okay, what is going to cancel out that's on top and on bottom? The x plus 1 or the x plus 4? Which one's present on top and on bottom? Okay, x plus 4s are going to be holes. So I want you to put over here, your discontinuity is going to be x equals negative 4, and it's a hole. Okay, your other discontinuity is the other thing that's left over on the bottom. What's the other thing left over on the bottom? X plus 1. And did it cancel out? So what is that called? A vertical asymptote. So I'm going to put x equals negative 1. And I'm going to put VA for vertical asymptote so you don't have to write it out every time. So negative 4, there's a hole in the graph. Negative 1, there's a vertical asymptote. Now, simplify is just whatever's left over from the equation. So since both of these guys crossed out, my simplified expression would be 8 over x plus 1. And that's your answer. Is this and then this. Got it? All right, turn over to the back. Let's do a couple more. So remember, they cancel out, they create holes. They don't cancel out, they create vertical asymptotes. Okay, look at number 2. Okay, the top is already done for us again. That's good. X minus 2, x plus 6. But then on the bottom, I have to break that 2x plus 12 up. So we just did a T-chart. The other two examples or options are GCF or difference of perfect squares. Which one is the bottom here? Do they have anything in common? They can both divide by 2. So I'm going to put GCF divide by 2. Now, when you divide by 2, you have to put the 2 in the front. And then I'm going to put what's left over in the parentheses, just like we did on those first 3 examples. So when I divide 2x by 2, what do I get? Just an x. What about 12 divided by 2? Plus 6. Okay, then look on the bottom. Do I have anything on the bottom that can cross out? Okay, x plus 6's are going to cross out. Does that make it a whole or a vertical asymptote? Whole. And where is the whole if it's x plus 6? Minus 6. Very good. And then I'm going to put whole. Now, the only place that you care about x's are if they're left over on the bottom. So do I have any other x's that are left over on the bottom? No, then you're done. So it'd be x minus 2 over 2. And that's your answer. Okay, so even though these are left over, since they're on the top, nobody cares. Okay, it's dividing by 0 you're not allowed to do. Okay, go down to number 3. Okay, top is already done for me. Y equals x plus 3, x minus 1. Okay, look at the bottom. We already did a t-chart. We already did a GCF. The last example is the square root one. So I'm going to square root both of these guys. And I'm going to do difference of perfect squares. Difference of perfect squares. What's the square root of x squared? X. And then what's the square root of 9? Plus or minus 3. So I put a plus 3 in one. I put a minus 3 in the other. Right? Okay. Then from there, I look for the ones that cross out. Which ones cross out here? Okay. And if the plus 3's cross out, what is x going to equal? Negative 3, and it will be a whole or a vertical asymptote. That one will be a whole because it crossed out. Okay, then what else is left over on the bottom? Not the top, just the bottom. And if it's an x minus 3, then the answer is x equals normal 3, and that's a vertical asymptote. Okay, remember the difference. If it cancels out, it's a whole. Doesn't cancel out, it's an asymptote. Then what's left over from my simplify step? X minus 1 over x minus 3. Good? Yes?
Why did you put x plus 3 and x plus 3?
We did that right before you came in. That's a shortcut. So if these are both perfect squares, then you can do what's called difference of squares. So like if it was this, x squared can be x times x. 25 can be 5 times 5. So you would break it up into x, and then this one would be plus 5 and minus 5. It's a shortcut. You can always do it if these are both perfect squares. Okay? All right, so come down to number 4, please. Okay, which part is already done for me on this next one? Top or bottom? Top's already done. X minus 2. On the bottom, though, we're going to have to use what method? GCF, difference of squares, that shortcut, or t-chart? T-chart. Negative 10 at the top. I could do 1 times 10 or 2 times 5. Which one is going to give me a 3 when I subtract? Okay, 2 minus 5 or 5 minus 2? 5 minus 2, very good. So then my factors are x minus 2 and x plus 5. Okay? Then from there I look for the holes in the graph that are going to cross out. What's going to cross out here? Okay, and if minus 2 crosses out, then where's the hole in the graph? Positive 2, right? Because you always switch the sign. Okay, that's a hole. And then my asymptote's what's left over on the bottom. So if it's a plus 5, my asymptote's at negative 5. And then for your simplify, you just put whatever's left over. So I have an x left over on top. I have an x plus 5 left over on bottom. And that'd be your answer. Make sense? Okay, 2 more left. Look at number 5. Okay, this time you have to factor both. This is how most of your homework is. Okay, so on the top, what method am I going to use? Difference of perfect squares. That's the shortcut. And then what am I going to use on the bottom? T-chart. So you just have to know which of those 3 types. It's only those 3 that you're going to have to do. All right, so y equals. Let's do the top first. Square root, square root. What's the square root of x squared? X, so I put an x in both. And then what's the square root of 49? Plus or minus 7. So I put a plus 7 and a minus 7. Okay, now let's do our t-chart. Set up your negative 14. Only way to get 14 is 1 times 14 or 2 times 7. Which one will subtract to give me 5?
2 times 7.
Which way do I minus? Minus on the 2. Good. So then I'll have x minus 2 and x plus 7. Okay, then you look at your terms to see who can cancel out. Who will cancel out? Okay, the plus 7s are going to cross out because there's one on top, one on bottom. And then that means I'm going to have a whole at x equals minus 7. Because remember, they're always opposite signs of what's in the parentheses. And then for my second one there, what's left over on the bottom? Minus 2, which means I have a vertical asymptote at what number? Not minus 2, but positive 2. You got it. Okay? Then for your simplify step, you just put whatever's left over. So it'd be a x minus 7 left over on the top and x minus 2 left over on the bottom. Okay? All right, last one. Okay, take a look at number 6. We got to factor the top and the bottom. What method is the top? GCF. What can they both divide by? Okay, I'm going to put GCF divide by 4. And then on the bottom, what method are we using? T-chart. Good. And it's just those same 3 methods over and over again. Okay, let's do the top first. My 4 goes in the front. Remember, it doesn't just go away. And then I want to divide 4x by 4. What's left over? X. And then 20 divided by 4. 5. Minus 5. Okay, top's done. Now I look at the bottom. I want to t-chart it. So I have x squared minus x minus 30. Okay, let's think about our factors of 30. We could do 1 times 30, 2 times 15, 3 times 10, 4 doesn't work, 5 times 6. Okay, in the middle, what number do I want if it's just a minus x? That's a minus 1. So which pair do I want? 5 minus 6. Very good. So put the minus on the 6, put your x on the bottom. And then it'll be x plus 5 and x minus 6. Okay? Look at the top and the bottom. Did anything cross out? Okay, almost, but the 5s don't have the same side. Then they can't cross out. So do I have any holes in this graph? Okay, for my hole, I'm going to put none. Okay, because nothing crossed out. But am I going to have some asymptotes? Yes. How many asymptotes am I going to have this time? 2. I'm going to have one at, if this is an x plus 5, what will it be? Minus 5. And then if this is a minus 6, it'll be at positive 6. Okay? And then for the simplify, I'm just going to put same. Okay, since nothing crossed out, I don't really have to change it because it's already the right answer. Make sense? Okay, perfect. So you have your homework on your desk. If you were absent on Friday, then I'm going to get you to take your test. If you were not absent on Friday and you need extra time, you can come after school if you need extra time to finish, but you probably shouldn't. Okay?